Hello everyone, and welcome to Earth Archives. Today, we're going to talk about the giant of the solar system, Jupiter. First, I'd like to ask, can you briefly tell me how big Jupiter is?
Jupiter, as the giant of the solar system, is truly an awe-inspiring presence. Its diameter is about 11 times that of Earth. If we imagine Earth as a small ping-pong ball, then Jupiter would be a massive basketball, dominating the entire stage. Not only is it huge in size, but its mass is also astonishing, 2.5 times the combined mass of the other 7 planets in the solar system, making it an undisputed heavyweight champion. This gas giant is mainly composed of hydrogen and helium, with no distinct solid surface. Its outer layers consist of thick gas clouds, while its interior may have a core made of metallic hydrogen and rock. Jupiter's powerful gravitational field not only firmly controls itself, but also attracts and influences many smaller bodies in the solar system, even serving as a guardian protecting Earth from some comet and asteroid impacts. Moreover, Jupiter's storms and cyclones are equally impressive, with the most famous being the Great Red Spot, a gigantic storm that has lasted for hundreds of years, large enough to fit 3 Earths inside. Its ever-changing striped bands showcase Jupiter's complex and dynamic atmosphere, fueling endless imagination and challenges for scientists studying gas giants. Jupiter is not just a giant star. It also has at least 84 known moons, the most famous being the Galilean moons, Io, Europa, Ganymede, and Callisto. Each of these moons has unique features, especially Europa, where scientists believe there may be an ocean beneath its icy surface, possibly capable of supporting life.
Wow! Does it rotate fast?
Jupiter's rotation speed is incredibly fast, almost unbelievable. It takes less than 10 hours, specifically about 9.9 hours, to complete one full rotation. In comparison, our Earth takes a full 24 hours, which means a day on Jupiter is less than half as long as a day on Earth, rotating more than twice as fast. This ultra-fast rotation makes Jupiter one of the fastest spinning planets in the solar system. This rapid rotation has a significant impact on Jupiter's appearance. Due to centrifugal force, Jupiter is bulged at the equator, creating a noticeable equatorial bulge, and the entire planet takes on a distinctly flattened, oblate shape. This shape is not only a direct result of physical forces, but also makes Jupiter visually very different from the more spherical planets, making it a key focus for astronomers. The fast rotation also affects Jupiter's atmosphere and magnetic field. The rapid spin generates strong Coriolis forces that drive the atmosphere to form striped bands and storms, like the famous Great Red Spot, which has persisted as a giant storm for so long because of this dynamic atmospheric environment. Jupiter's magnetic field is also exceptionally strong due to its rapid rotation, making it the planet with the strongest magnetic field in the solar system, influencing its surrounding moons and space environment.
How far is Jupiter from Earth?
The distance between Jupiter and Earth isn't fixed. It varies depending on their positions in their orbits. When Jupiter and Earth are on the same side of the Sun, the distance is about 590 million kilometers. This astronomical event is called opposition. At this time, Jupiter is closest to us and is the best time to observe the planet. On the other hand, when Jupiter and Earth are on opposite sides of the Sun, the distance stretches to about 921 million kilometers, a position known as conjunction. At this point, Jupiter is much farther away, making observation more difficult. To better grasp how vast this distance is, we can use speed as an analogy. Suppose you could board a high-speed train traveling at 390 kilometers per hour, which is already one of the fastest rail speeds on Earth. Even at this astonishing speed, it would take nearly 184 years to reach this giant gas planet. This number helps us realize just how immense the distances between planets in the solar system are, far beyond what we experience in everyday life. Jupiter's vast distance hasn't stopped human curiosity and exploration. On the contrary, This sense of distance has inspired countless scientists and space probes to embark on daring adventures. Multiple missions have successfully flown by or entered the Jupiter system, bringing back rich data that has unveiled many of Jupiter's mysteries. These probes not only had to endure long journeys, but also had to withstand Jupiter's intense radiation environment, challenges that highlight both the difficulty and grandeur of space exploration.
How about Jupiter's gravity?
Jupiter isn't just the largest planet in the solar system. It's also a heavyweight giant with incredibly strong gravity. Its gravitational pull is about 2.5 times that of Earth. This means if you weigh 100 pounds on Earth, standing on Jupiter would instantly make you weigh 250 pounds. This powerful attraction makes Jupiter an undeniable presence in the universe. However, Jupiter's influence goes beyond just changing your weight. It plays a crucial role in protecting Earth. Jupiter's immense gravity acts like a natural shield, attracting and capturing many small comets and asteroids, preventing them from heading straight toward Earth. If these objects were to collide directly with Earth, the consequences could be catastrophic, potentially affecting the evolution of life here. Jupiter's presence greatly reduces the chances of such disasters. For this reason, Jupiter's title as Earth's guardian is well-deserved. It's not only a heavyweight player in the solar system, but also a giant protector of our home. Many astronomers believe that thanks to Jupiter's steadfast protection, Earth has remained relatively safe, allowing life to flourish and evolve into the diverse and rich forms we see today.
Jupiter is so huge. Does it have a solid surface you can stand on?
Jupiter, the largest and most spectacular planet in the solar system, doesn't have a solid surface like Earth. It's a typical gas giant, mainly composed of hydrogen and helium, with almost the entire planet surrounded by thick layers of gas. This structure gives Jupiter its overwhelming volume and mass, but there isn't really a ground to stand on. If humans tried to step onto Jupiter, you'd find that beneath your feet isn't solid rock or soil, but dense, heavy layers of gas clouds. As you go deeper, the pressure and temperature increase dramatically. Jupiter's powerful gravity would pull you further down into thicker gas layers, eventually crushing you with pressure so intense that breathing would be impossible, and standing would be out of the question. It's not like walking on Earth. It's more like being swallowed by an invisible force. Jupiter's gaseous makeup also gives it a unique appearance, colorful cloud bands and massive storms, like the famous Great Red Spot, a storm larger than Earth that has lasted for centuries. These dynamic airflows and storms showcase the vibrant and ever-changing nature of this gas giant. In short, Jupiter is a planet without a solid surface. Almost the entire planet is one enormous ball of gas. Its grandeur and mystery don't lie in a surface you can land on, but in its layered clouds and swirling storms. For humans, Jupiter is an unwalkable giant gas ball, a unique and challenging world in our solar system.
That sounds dangerous. So, what's the weather like on Jupiter?
Jupiter, this magnificent gas giant, is not only huge in size, but also home to incredibly violent storms. Its wind speeds are astonishing. At minimum, they reach 320 kilometers per hour, already several times stronger than the most intense hurricanes on Earth. But that's not the limit. In the famous Great Red Spot region, wind speeds soar to a staggering 680 kilometers per hour, creating a superstorm that has lasted for centuries. This storm is like a massive spinning vortex, capable of destroying any building on Earth, showcasing the extreme and dangerous nature of Jupiter's atmosphere. That's not all. Jupiter's interior is even more terrifying. Scientists estimate that Jupiter's core temperature may reach up to 50,000 degrees Celsius, several times hotter than the surface of the Sun. Under such extreme heat and pressure, any object deep in the atmosphere would instantly vaporize and vanish without a trace. This makes Jupiter utterly unsuitable for human exploration or habitation, more like a death planet, with no place for life to survive. Jupiter's violent wind speeds and scorching core reveal the true nature of this gas giant, a planet ruled by extreme conditions. Its thick and unstable gas layers constantly form and dissipate storms, with turbulent airflows bursting with incredible energy. The Great Red Spot is like Jupiter's eternal mad heart, continuously spinning and displaying one of the most powerful storms in the universe.
Since Jupiter itself is so extreme, is there any possibility of life on its moons?
Jupiter, as the giant of the solar system, is not only magnificent on its own, but also has a rich and diverse system of moons. Currently, we know of as many as 95 moons orbiting it. The most famous are the four members of the so-called Galilean moons, Io, Europa, Ganymede, and Callisto. These four moons differ greatly in size and characteristics, and are key focal points for scientists exploring the mysteries of the solar system. Io, Jupiter's first moon, is the most volcanically active body in the solar system. Its surface is covered with lava flows and volcanic craters. Due to Jupiter's powerful gravitational pull, Io experiences intense tidal friction in its interior, making it an endlessly volcanic planet, with glowing lava that shines like a fiery flame. Europa, the second moon, is famous for its cold, smooth, icy surface. What's even more exciting is that scientists speculate there might be a vast liquid ocean beneath its ice layer. This hidden ocean is a prime target in the search for extraterrestrial life because water is essential for life as we know it. Europa's mysterious ocean could be a crucial starting point for humanity's quest to find life beyond Earth. Ganymede, the third moon, is the largest moon in the solar system, bigger even than the planet Mercury. It has its own magnetic field, indicating a complex internal structure and possibly an underground ocean, which also makes it a focus of scientific study. Callisto, the fourth moon, is known for its ancient surface, covered with impact craters. It preserves traces of the early history of the solar system and serves as an important key to understanding planetary evolution. These Galilean moons are not just Jupiter's companions. They are vital clues in unraveling the mysteries of life in the universe. Each has unique geological and environmental features, providing rich subjects for research. Especially Europa's underground ocean inspires endless hope for the existence of extraterrestrial life.
What about Io?
Io is one of Jupiter's most unique and awe-inspiring moons. It's known as the volcanic L, with over 400 active volcanoes, making it the most volcanically active body in the solar system. The volcanic landscapes on Io are vast and powerful, with lava eruptions that can shoot hundreds of kilometers into the sky, showcasing some of the most astonishing natural energy releases. Io's volcanic activity is caused by the strong gravitational pull of Jupiter and the tidal forces from its other moons. This complex gravitational tug creates intense friction and heat inside Io, melting rock and forming active lava lakes and volcanic craters. Each eruption continually reshapes Io's surface, which shines with a variety of colors, yellow, red, black, and white, like a magnificent painting woven from flames and rock. The sulfur and other minerals spewed from the volcanoes cover Io's surface, giving it its unique, vibrant colors, which scientists can observe through telescopes. Io is not only a geological marvel, but also an excellent example for studying tidal heating and planetary internal dynamics.
What about Europa?
Europa, also known as Jupiter's second moon, is one of the most fascinating moons in the solar system. It is covered by a thick ice shell, with a cold and hard surface averaging about -163 degrees Celsius, like a frozen world. However, beneath this icy crust lies a huge secret. Scientists believe Europa harbors a vast liquid ocean, primarily maintained by intense tidal heating. Jupiter's powerful gravitational pull stretches and flexes Europa, generating internal friction and heat. This internal heat keeps the ocean beneath the ice in a liquid state, despite the extremely cold surface. This hidden ocean beneath the ice is considered one of the most promising places in the solar system for potentially harboring life. It may host ecosystems similar to Earth's deep-sea hydrothermal vents, providing energy and nutrients necessary for life. Europa's icy surface is covered with cracks and faults. These ice fractures might indicate seawater rising or the ice shell refreezing, revealing dynamic activity between the ocean and the surface. These geological processes not only support the hypothesis of a liquid ocean, but also fuel humanity's endless imagination for exploring Europa's deep seas.
What about Ganymede?
Ganymede, Jupiter's third moon, is the largest moon in the solar system, even bigger than Mercury. This massive icy world has a surface covered with an ice shell, but its true charm lies beneath that ice. Scientists have discovered that Ganymede possesses a vast underground ocean, containing more water than all of Earth's oceans combined. This astonishing fact makes it a key target in the search for extraterrestrial life. Another unique feature of Ganymede is that it has the only known magnetic field among moons in the solar system. This magnetic field not only protects Ganymede's surface from severe space radiation, but also suggests a complex internal structure, including an iron-nickel core similar to Earth's. The presence of this magnetic field makes Ganymede an ideal object for studying moon geology and internal dynamics. Although Ganymede's atmosphere is very thin and primarily composed of oxygen, this oxygen is not breathable for humans. Nonetheless, its thin atmosphere helps support some chemical processes on the surface, increasing the possibility of life. The combination of its underground ocean and magnetic field makes this icy moon full of mysterious potential for life.
What are the characteristics of Callisto?
Callisto, Jupiter's fourth largest moon, is also one of the most heavily cratered bodies in the solar system. Its surface is covered with countless impact craters of various sizes, resembling an ancient cosmic map that records billions of years of intense bombardment by meteoroids and comets. These craters demonstrate Callisto's long history within the solar system and make it an important window for studying planetary impact history. Callisto's environment is extremely cold, with a thick icy surface. Its geological activity is relatively quiet, quite different from the volcanic Io or the ocean-bearing Europa. This geological calmness makes Callisto seem less likely to support life, and scientists generally consider the possibility of life there to be low. However, Callisto's stability is also one of its valuable traits. This vast and relatively safe icy plain could serve as an ideal base for future human exploration of the Jupiter system. Whether it's for building space stations, setting up scientific laboratories, or acting as a transfer station for humans traveling to more distant planets, Callisto offers unique and favorable conditions.
Speaking of Jupiter, I'm sure everyone wants to know about the Great Red Spot, right?
The Great Red Spot on Jupiter is one of the most famous phenomena in the solar system. This massive anticyclonic storm is about 40,000 kilometers in diameter, large enough to fit 2 to 3 Earths inside it. Imagine the entire Earth surrounded by a raging storm with wind speeds reaching an astonishing 680 kilometers per hour, several times stronger than the most powerful typhoons on Earth. This fierce storm has been swirling continuously in space for over 4 centuries, becoming both a mystery and a treasure for scientists. The Great Red Spot is not only a symbol of Jupiter, but also an excellent laboratory for studying planetary atmospheric dynamics. Its existence allows us to glimpse the complex storm systems of gas giants and understand how such gigantic atmospheric vortices form, sustain, and eventually dissipate. Over time, scientists have observed that the size of the Great Red Spot has been shrinking and the intensity of the storm fluctuating, providing rich data to help us predict weather changes and understand Earth's climate shifts. Jupiter's Great Red Spot is also a rare example of a long-lived storm in planetary climate systems. Its energy comes from Jupiter's internal heat and rapid rotation, enabling this storm to persist even longer than the entire history of human civilization.
How are Jupiter's auroras different from Earth's auroras?
Jupiter's auroras are among the most spectacular and mysterious natural wonders in the universe. Compared to Earth's auroras, Jupiter's are not only more intense and longer lasting, but their brightness can be tens of times greater than those on Earth. These dazzling lights mainly occur in the ultraviolet spectrum, displaying enchanting blue-purple hues far beyond the range visible to the human eye. Because of this, we need special ultraviolet telescopes to catch a glimpse of this cosmic spectacle. The origin of these lights comes not only from the solar wind stimulation, but also from a more mysterious contributor, Io, one of Jupiter's moons. This volcanically active satellite constantly releases large amounts of charged particles. Under the influence of Jupiter's powerful magnetic field, these particles collide violently with gases in the atmosphere, creating the breathtaking auroral display. Io's volcanic activity acts like a power generator for Jupiter's auroras, continuously injecting energy to keep this light show ongoing. Jupiter's magnetic field is one of the strongest in the solar system, extending even beyond Earth's orbit. This makes the auroras near Jupiter's poles display an unprecedentedly powerful and stunning effect. These auroras are not only beautiful, but also serve as a vital window for studying the complex interactions among Jupiter's atmosphere, magnetic field, and its moons.
Does Jupiter have rings?
Jupiter's rings. Just hearing the name might make people think of Saturn's magnificent and dazzling rings. But in reality, Jupiter's rings are very subtle and faint, almost impossible to see with the naked eye. These rings are mainly made up of countless tiny dust particles and small rocks, far less spectacular and bright than Saturn's. They are like delicate yet inconspicuous jewelry, quietly orbiting this gas giant. The formation of Jupiter's rings has a unique story. Scientists have found that most of the dust comes from Jupiter's small moons. When these moons are struck by meteoroids from space, material on their surfaces is shattered into fine dust and fragments, which then disperse into orbit and form these thin, scattered rings. This dust flowing from the small moons continuously replenishes the rings, keeping them faint but stable. Although these rings aren't as grand and impressive as Saturn's, they hold invaluable scientific significance. Jupiter's rings reflect the dynamic environment of the Jupiter system, especially the complex gravitational interactions between the moons and the planet. By studying the distribution and movement of this dust, scientists gain deeper insights into Jupiter's magnetic field structure, the surface properties of its small moons, and even the micrometeoroid flux around Jupiter, helping to unravel the mysteries surrounding this giant planet.
What is the history of human exploration of Jupiter?
Humanity's journey to explore Jupiter is like an epic space saga. Starting in the 1970s, scientists sent multiple spacecraft to this largest planet in the solar system, gradually unveiling its many mysteries. Pioneer 10, launched in 1973, was the first spacecraft to fly close to Jupiter. It revealed Jupiter's powerful magnetic field and complex radiation belts for the first time, laying the groundwork for future studies. Following that, Voyager 1 and Voyager 2 arrived in 1979, sending back stunning images of Jupiter's massive storm systems and ring structure. These missions allowed humans to visually experience the grandeur of this gas giant and discover its diverse and colorful moons. In 1995, the Galileo spacecraft entered Jupiter's orbit and conducted detailed observations for 8 years. It carried out unprecedented in-depth studies of Jupiter and its moons, especially investigating the icy moon Europa. Galileo's discoveries of a possible underground ocean there sparked immense excitement about the potential for extraterrestrial life. More recently, the Juno spacecraft arrived in 2016 to orbit Jupiter, focusing on the planet's internal structure and powerful magnetic field. Juno has returned a wealth of precious data, reshaping scientists' understanding of Jupiter's core and atmospheric dynamics, and helping us better grasp how Jupiter influences the evolution of the entire solar system.
Lastly, I want to ask, what will happen to Jupiter in the future?
Jupiter, the largest planet in our solar system, has an astonishing mass, but will never become a true star. Although its mass is more than 300 times that of Earth, it is still not enough to ignite nuclear fusion. In other words, Jupiter will never light up like the Sun or become a small star. Nevertheless, its role in the solar system is far from insignificant. In fact, because it doesn't burn, it serves as an important guardian for Earth and the other planets. Jupiter's enormous gravitational field acts like an invisible shield, constantly maintaining the balance within the inner solar system. It attracts and captures many asteroids and comets, preventing them from directly hitting Earth, thereby reducing the risk of catastrophic impacts. Thanks to Jupiter's presence, Earth has been able to nurture life in a relatively stable environment, a protection that is both significant and profound. Moreover, Jupiter's strong gravity not only influences nearby small bodies, but also affects the orbits of objects throughout the solar system. It helps maintain the orderly paths and rhythms of the planets, acting like the solar system's stability master. By preventing orbital chaos and violent collisions between celestial bodies, Jupiter ensures the stability and harmony of the entire system.
Awesome! I learned so much about Jupiter today. It's truly amazing. Remember to subscribe, like, and leave a comment so we can continue exploring the mysteries of the universe together.
Absolutely. Jupiter isn't just huge and mysterious. It's also closely connected to Earth. It's the giant of the solar system and a key target for our exploration of the universe.